learning targets, so I'll title each page. So this is LT1. LT1 again is dealing with sig figs. So you're going to have to know what are your, let's not start with that one. Let's start with your non-zero numbers, what it means to be trapped, trailer, and then we'll put placeholder in a different color. Let's put it even on a different page. Okay, a non-zero number is any number between 1 and 9. A trapped occurs when you have like 7, 0, 8. That 0 right there is trapped because it's between the 7 and the 8, which are two non-zero numbers. It doesn't matter if it's 0.708. That's still trapped because it's between two non-zero numbers. And then, of course, there's the exact number if you have 700 decimal point, where those zeros do count because if you said it, you said exactly 700. The trailer are the numbers that come after the decimal point, so this can be as simple as 55.00. These two zeros here would be trailers. The easiest way for some of you, if you're iffy on trailers, is to type in 55.00 into your calculator, hit enter, and watch the zeros disappear. Then they must be trailers. And then trailers can come after like 0.5500, where these zeros here again would be trailers. They don't really need to be there, but they are because that's how accurate your measurement was. And then the last type, do not count, are placeholders. Placeholders do not count because they just give the number of value. So the easiest placeholder to start off with is 77,000. These zeros here are placeholders. Placeholders do not count, so therefore this one would only have two sig figs, because the 7 and the 7 are both non-zero numbers. And then you can go the other way. 0.007010 would be one. You could go through and tackle the easy ones first, the non-zero. Then this 0 right here becomes trapped because it's between the two non-zero numbers. This 0 on the end is a trailer because it doesn't need to be there, but yet it is because for accuracy purposes. And then that would mean these two zeros here are placeholders. So if you looked at this number here would have 4 sig figs. Remember, when you read a device, it's always, so if this is 10 and this is 11, and your measurement was here, it's 10, and then you guess one spot. The part where some people forget to is sometimes when all of a sudden you have, I didn't make that big enough. Let's do this 10, this 11, and then let's throw our little lines in here. And each one of those little lines, need one more up there, would be 0.1. Oh, I need one more on the bottom too. I really ran out of room. So then if this was here, I know for sure it's 10.8, and then I guess. And the guess is whatever you have, and that's what I'm going to look for when you do this. I don't care what the number is as long as you guessed. Alright? So then LT2 deals with math. Remember, we have plus and minus, and plus and minus we only care about decimal places. And we want the least amount. So if you had 7.1 plus 10.24, you would add those up and you get 17.34, 17.34, and then you look at your decimal places. The 7.1 has 1 decimal point, the 10.24 has 2, which means my answer should only have 1 decimal point, so I go over 1 decimal point and I round. The 4 doesn't going to change because it's going to round down, so I get 17.3. And then multiplication and division, okay, we care about the number of sig figs, not how many decimal points. So these are rules that you're going to have to keep straight. So let's say we had 10.0 times 14. equals. All right. So the first thing you're going to have to do is tell me how many sig figs are in each of these numbers. I'll handle the 14 first. That's the easy one because I have two non-zero numbers. 10.0. Why would someone put that 0.0 there? It doesn't mean anything. So it must be important. So therefore 10.0 actually has 3 sig figs. The 1 is a non-zero number. This 0 here is a trapped and this 0 here is a trailer. So this has 3. So if you do your math, you take 10.0 times 14, you would get 140. Okay? And if some people were going like that, and you only need 2 sig figs, hey, that 0 is not going to change it, so I get 140. This 0 here is a placeholder, so therefore it does not count as sig fig. So I'm done. Math with sig figs. If you want to try some more again, you can grab the book and go to the chapter that has math with sig figs on it. All right. So then LT3 are your metric prefixes. Okay. It's as simple as knowing what are the big ones. So if I put my base unit right, I don't know what that was. I'm going to thank my dad for that one. Dyslexia there. So then you have your base unit. So where does kilo? Is kilo bigger or smaller? Kilo is bigger, so kilo goes up on top. Only one L in kilo. And kilo is 1,000 times bigger. What does that mean? 1 kilogram equals what, Katrina? Yeah, 1,000 grams. All right. So then the other prefixes we have are centi. Centi means 1/100th. So what's bigger? A gram or a centigram. If you have problems with that one because that doesn't picture you, picture a meter. What's bigger, a meter or a centimeter? Why a meter is much bigger, so therefore I have 100 centimeters because there are cents in 100 cents in a dollar. And then the last one is milli. A milli is 1,000th. And millimeters are actually 10 times smaller than a centimeter. So then 1 meter would be 1,000 millimeters. So you're going to have to learn those. LT4 are what are you going to measure length in? Volume, mass, and temperature. So you should know these already. I'm not going to give you. And I'm concerned with the base unit. The base unit is the one that's repeated every time. So like for example, what's the base unit on these? It's the M. The meter is the base unit. All right. So then you have LT5, which are unit conversions. Okay, so what's going to happen in here is I'm probably going to combo learning target 3 and 5 together because why bother making 2 separate problems when I can go in here. So let's say if we have 4.5 kilograms, I would like to know how many grams that is. So then you go 4.5 kilograms times line. And if you see grams on top, kilograms on top, then kilograms have to go on the bottom and grams. So again, you just have to fill in the numbers. Units cancel out. And I get grams. And this is 2 sig figs, so I have 2 sig figs. And the other thing would be doing like a cube to cubed. So if we had 1.4 meters cubed, and I wanted to know how many centimeters cubed that was, you would write 1.4 meters cubed times line times line times line equals centimeters cubed. All right. So the issue you have on here is 1 meter does equal 100 centimeters. However, 1 meter cubed does not equal 100 centimeters cubed. If you want a visual for this, take a meter stick, 3 of them, put them on the corners of your axes and make a cube, and take 100 of your pinky fingers, your tips, Would that fill that giant box that is over? No, not even close. So then I'm going to put 1 meter here, 100 centimeters here. What, remember, m cubed is, it's really m times m times m. So that takes care of one of your m's. So then I repeat. One of the funniest wrong answers people do is they keep flipping these things right here. And they put 100 over 1, then they put 1 over 100. Well, what happens? They would all cancel off, and then we do it one more time. And I have 2 sig figs centimeters cubed. So there's unit conversions. LT6 was the lab, so as long as you did the lab, holy cow, how dense things are, you should be good. LT7 is density. So D equals M over V. One of the first things I'm going to have you do is do some algebra. So let's circle the M. So I want to know, what does M equal to? M, well, let's see. If I want to get the M all by myself, that means I got to get rid of the V. So I get M equals V times D. All right. One of the other things that you should be able to do is you should be able to tell me what units all of these have. Like, for example, mass is in grams, volume is in milliliters or centimeters cubed, because they're the same. So therefore, density will actually have both units, grams per milliliter. And if you want to do a quick double check on here to see if the units are correct, you'd put grams equals milliliters times grams over milliliters, because that's the units for density. Your milliliters cancel out, and voila. So then we got the next one where we have D equals M over V, and now we want to solve for the V on the bottom. So the problem that you run into is that some people try to do this. Yeah, that just doesn't work. When they're both on the same level, they don't get rid of anything. So what you're going to have to do is let's make 2 fractions. Because once you have 2 fractions, how are you going to solve for a variable? You're going to cross multiply. So then you get dv equals m. Well, that doesn't do you any good. So then, now, how do I get the v all by itself? Since I'm multiplying, that means I must divide. All right? So then my densities cancel out on the left side, and I get v equals m over d. All right? So let's just give you a little example problem to see if you can do this. Let's say if the mass is 14.0 grams, and my density is 3.14 grams per milliliter. Could you find the volume? So again, we remember D equals M over V. Oh, I'm looking for the V, so that means I'm going to have to do some algebra. Cross multiply, V times D equals M. Oh, I still need the V all by itself. So I divide by D. So V equals M over D. That's part of the problem. And now you have to plug in your numbers. So then I have 14.0. Yep, I need to see that grams there. Divided by 3.14 grams per milliliter. All right, your grams cancel out, and you end up with milliliters. And since I have 3 sig figs here and 3 sig figs here, I need 3 sig figs there. If you're unsure how the units work out on this, how it magically becomes milliliters, all right, remember, you don't divide by fractions, you actually what? Multiply by the reciprocal, so I'm going to get 14.0 grams times milliliter over 3.14 grams. What happens with the grams? They cancel out, and it leaves milliliters left behind. All right, so here's your review for Unit 1. Any part you're struggling on? Watch video. Go to YouTube. YouTube how to do a density problem or a unit conversion or something else like that.